First of all, here's my little illustration of the problem. Okay, so first we're going to break this up and so we can get the equations that we need to solve for the problem. First of all, we need to break it up into initial velocity components. For the v initial x component, we get the v velocity initial cosine theta, so that's going to equal 55 times cosine 52, which gives us 33.86 meters per second squared on the x-hat. V initial y is going to be vi sine theta, which is going to be 55 times sine 52, which is 41.34. So now we can take a few routes. So to find the max height, the equation was given to us. Now if we let the v final equals 0, well, yeah, that's going to give us this one right here. It's going to give us this one right here if you let vy equal final. So that just cancels out, to be honest with you. So how we got this one was we said eliminating the time interval using v final minus vy initial is equal to the a initial times delta t. So pretty much that's going to yield and give us this equation right here. Okay. So we circled that one, so we got the final time to find the max height. So to find the max height from here to here is going to be this equation right here. Now I went and I found the time. This equation right here, it gave us, we can say that the initial height and final heights are the same. The time of flight is twice the time it took to get from here. So really what I'm trying to say is the time it took from here to get here at the maximum height, if you multiply that by 2, will give us the time it took from here to the final time. So and you can see what I did here. V y final equals the v initial y times acceleration dt. We set vy final equal to 0, so that gives us 0 equals v initial y plus ay delta t. Bring it over, divided by dt, and that gave us dt equals to dt equals to negative vy initial times ay. So that's to give us half. So to get the final time, you just multiply it by 2, like I said earlier. So now that we have all our equations, we have this one. Oh, I forgot one. To get the range, to get the final distance it took from point A to point B, we get this equation right here. Okay. So now that we have all our stuff we need, we have the max height, the range, and the time. So now we just come down here and just plug in numbers. The max height is going to be dy, delta y equals to negative 43.34 squared divided by 2 times negative 9.8 meters per second squared, and that came to give us 95.84 meters. Okay, so now we move on to final time. Final time is going to be delta t equals to negative 43.3. I can't see that. 43.34 meters per second divided by negative 9.8 meters per second squared, and that gave us delta t equals to 4.2 seconds. So you get the final time, you just multiply that by 2, and you get 8.85 seconds. Now for the range, plug in numbers. Delta x equals to 33.86 meters per second times 8.85, seconds, and that gives us delta x equals 229.5 meters. So going back up here, we're going to look at the draw and plug-in numbers. The max height that this rock traveled is 95.84. The time it took to get to that max height was 4.42 seconds, and the total travel time of this rock was 8.85 seconds. And the total distance it's traveled from here to here is 229.5 meters. So